Welcome everybody, this is Mr. Regener and this is our Chapter 2 review for Part 1 of our test. We're going to be using our study guide and you may be wondering to yourself, what in the world is on Chapter 2? Well, I'm glad you asked because we'll need to know how to add, subtract, multiply, and divide fractions, mixed numbers, and decimals. So we're going to be looking again at our study guide for Chapter 2 and we'll look at Part 1 in this video. If you'd like more information or would like to look at our study guide for Part 2, then please check out that in a separate video. So here we are on Part 1. Now Part 1 of our study guide is really similar to Part 1 of our test. We have to just simply do the computations just as it says. We want to show our work, show the steps in the algorithm, and certainly show our answer. So let's focus here on number 1 first. It says 7 3/5 divided by 2/3. We're taking this mixed number divided by a fraction. Before I can do anything, I need to take care of that mixed number and turn it into an improper fraction. So remember, I'm going to work around the clock, kind of multiply my 5 times 7 plus 3. So I'm going to put a little multiplication sign and a plus sign there so I remember. 5 times 7 is 35 plus 3 is 38. So that becomes 38/5 divided by 2/3. Now I also know that I should keep, change, and flip every time I'm dividing fractions. So I'm going to do that. 38/5 times 3/2. So now I need to look and see if I can cross simplify. 5 and 3 do not have any common factors, but 38 and 2 do. In fact, the greatest common factor between 38 and 2 is 2. So 2 divided by 2 is 1. And 38 divided by 2, let's see, that would be 2 goes into 3 once. 2 goes into 18 9 times. So that's 19. So now I have 19 times 3 and 5 times 1. I'm going to put that over here, maybe to save space. 19 times 3, that's going to be, well, let's see, 3 times 9 is 27. And then 3 times 1 is 3, plus the 2 is 5. So that's 57 over 5, or 57/5. I need to turn that now back into a mixed number. Remember, this fraction as it's written could be read as a division problem. 57 divided by 5. And that's exactly what I'm going to do. So I'm going to take my scrap sheet of paper here. There it is. And work this out just as I would advise anyone to do. So I'm going to take 57 divided by 5. And you can do this on your test as well. So 5 goes into 5 one time. That's 5. Subtract, I'm left with 0. Bring down my 7. 5 goes into 7 one time. 1 times 5 is 5. I have 2 remaining. Remember, that 2 becomes my new numerator, and the 5, the divisors, is my denominator. So my answer here is 11 2/5. So notice the steps that went into that. That's where your points are coming from. We want to show our algorithm, show our answer in its simplest form. Now we move on to number 2. It's 5/6 divided by 3/8. So again, I want to keep these fractions, but keep, change, flip. I don't have to worry about the mixed number here because they're just fractions. So I'm going to keep 5/6, change my sign to multiplication, and then flip or use the reciprocal of 3/8, and that's 8/3. Now I can look at cross simplification. 5 and 3 one more time. I cannot simplify them. 6 and 8 do have a common factor, and the greatest common factor between 6 and 8 is 2. So 6 divided by 2 is 3, and 8 divided by 2 is 4. Now I can multiply. 5 times 4 is going to be 20. And 3 times 3 is going to be 9. One more time, notice I've got an improper fraction, 20 divided by 9. I can do this on a separate sheet of paper, as I will do now. 20 divided by 9. Let's see, 9 doesn't go into 2, but 9 goes into 20. I'll say 2 times. 2 times 9 is 18. I can subtract and I get 2. We can now make this into 2/9 because my remainder was 2, and the divisor is 9. I want to check that out though, because 2/9, is that something that I can reduce? If I can, I should do it. Fortunately, I guess for us, we can't. So my answer then is 2 and 2/9. That's my final answer for number 2. Moving on, here's number 3. It says 7 1/5 divided by 9. So now I have a mixed number divided by a whole number. I need to turn this mixed number into an improper fraction. And I can also turn this 9, the whole number, into a improper fraction by putting it over 1. So 5 times 7 is 35, plus 1 is 36. So that's 36/5 divided by 9 over 1. So I can keep, change, and flip. KCF, 36/5 times 1/9. 1 and 5, there's no common factor there other than 1. And then 9 and 36 do have a common factor. In fact, if I think about this hard enough, I might be able to figure out what that is without doing a factor tree and all that other stuff. If you need to do factor trees to find the greatest common factor, then please feel free to do so. But if I think about this, like 9 times 4 is 36. So 36 has a factor of 9. 9 has a factor of 9. So 9 divided by 9 is 1, and 36 divided by 9 is 4. So now I can multiply across. 4 times 1 and 5 times 1. That's 4/5. And that just happens to be my most simplified answer, 4/5. Can't get any simpler than that. All right, moving along to this next set. In this one, it says divide and use the algorithm for dividing decimals. So I know I'm dividing decimals, and with that, I need to consider the idea of possibly moving decimals around. So I'm going to set these up in like a familiar form for me, and that is the regular division sign. So I have 75 and 25/100ths, and that's being divided by 5. Now my 5 is my divisor. There's no decimal there, so I don't need to move this one over to the right at all. Instead, I'm just going to move that right up to the top. Now I divide as normal. 5 goes into 7 one time. That would be 5. I'd subtract and get 2. Bring down my 5. That's 25. 5 goes into 25 5 times. 5 times 5 is 25. I can subtract. I get 0. I bring down a 2. 5 goes into 2 0 times. I'd bring down my 5. 5 goes into 25 5 times. That's 25. I subtract and I get 0. So my answer is 15 5/100ths. Notice a big thing here, and this is an error that sometimes people make. They get to this 2. They say 5 goes into 2 0 times. They bring down their 5, but they don't put the 0 there. We have to make sure we put that 0 there. Otherwise, we've made a big error that gives us the wrong answer. Moving on to number 5, it says 13 2/10 divided by 11/100ths. So I'm going to write it out. 13 2/10 divided by 11/100ths. Now here's a decimal in my divisor. I know I want to move that over to the right as many times as I can to make that a whole number. Remember, this decimal is like my copycat. It moves over the same number of spaces as I moved the divisor. With that being said, I've got a blank space here. I'm going to put a 0 there to fill in that blank space, and then float my decimal up to the top into my quotient. So now I can divide as usual. 11 doesn't go into 1, but it does go into 13 one time. That would be 11. That would be 2. Bring down my 2. 11 goes into 22 2 times. 2 times 11 is 22. I get 0. Bring down my 0. 11 goes into 0 0 times. So my answer here is 120. I've got that decimal at the end, but I don't really need it for a whole number. So my answer is just 120. Over here, now we're on number 6. I have 182 5/10 divided by 25/100ths. So let's set it up. 182 5/10 divided by 25/100ths. I have a decimal in my divisor that I need to move over 2 times. That means the decimal in my dividend moves over 2 times. I put a 0 there as my placeholder and then bring my decimal up into the quotient. Now it's just division time. 25 doesn't go into 1. It doesn't go into 18, but it does go into 182. If you don't know how many times, you can guess and check, right? So I'm going to take a fantastic guess here. Oh, let me just see here. Maybe I'll say 7. I don't know. I'm just feeling wild, right? So I'm going to take 25 times 7. 7 times 5 is 35. 7 times 2 is 14 plus 3. That's 17. And then, oops, that's all I need to do. So I get 175. Hey, look at that guess. That's a fantastic guess. So I'm going to write that down. That was 7 times. That would go above my 2. 7 times 25 is 175. Now I can subtract. So 2 minus 5, I can't do it. I need to borrow from the 8. The 8 becomes 7. The 2 becomes 12. 12 minus 5 is going to give me 7. 7 minus 7 is 0. 1 minus 1 is 0. So I have 7. Bring down my 5. 25 goes into 75. That's 3 times. Some of you maybe know that fact already. Some of you might have to work out on paper, and that's fine to do that too. Then I get a 0. 25 goes into 0 times. So these ones may be kind of easy for us. I'm not sure, but I get 730 as my answer. Let's move on now to the multiplication problems, numbers 7, 8, and 9. So, by the way, that's exactly why 6 is afraid of 7, because 7, 8, 9. So here we have 97 thousandths times 15. I'm going to set this up as a multiplication problem, and I'm not going to worry about decimals. I'm not lining them up at all. So I'm just going to write this out. 0, 9, 7, and 15. Notice I left off that 0 in front of the decimal point. We could add it. It won't change our answer. It's just going to give us another number to multiply by 0. So 5 times 7 is 35. 5 times 9 is 45, plus 3 is 48. And then 5 times 0 is 0, plus 4 is 4. Add my placeholder 0 now that I'm on to the tens place. 1 times 7 is 7, 1 times 9 is 9, 1 times 0 is 0. Now I need to add these numbers up. 5 plus 0, 8 plus 7. If I can write correctly, that would help. 9 plus 4 plus 1 is 14, and 1 plus 0 is 1. Okay, so my answer here looks like 1,455, but not so fast. I need to look back at my decimal moves. I don't know if this highlighter will show up, but I want to try it out. We'll see what happens. Right, so I have 1, 2, 3 moves there, and 0 moves here. Let's see. I can't really tell if that's showing up or not, but you get the idea. There are 3 moves in my first factor, 0 moves in my second factor. That means I need to move the decimal here from the right side 3 times. So 1, 2, 3. My final answer then is 1 and 455 thousandths. Very different than 1,455. That decimal point matters. Take a look at number 8. We have 32 hundredths times 64 hundredths. So it's going to work out that these are going to be lined up just because of the numbers that are given here. But I'm not doing that intentionally. I never have to worry about lining up decimals when I multiply. So 4 times 2 is 8. 4 times 3, yeah, that's right, is 12. Add my placeholder 0. 6 times 2 is 12. And 6 times 3 is 18, plus 1 is 19. Now I can add them together. 8 plus 0 is 8. 2 plus 2 is 4. 9 plus 1 is 10. 1 plus 1 is 2. It looks like 2,048, but we're smarter than that. We know that we have 2 decimal moves in my first factor and 2 decimal moves in my second factor. So 2 moves here, 2 moves there. That means I'm moving my decimal in my final product here 4 times. 1, 2, 3, 4. With that being said, my final answer then is 2,048 10,000ths. All right, moving on to number 9. 62 and 3/10 times 4 and 2/10. So 62 and 3/10 times 4 and 2/10. Again, it worked out numbers-wise that I just happened to have the decimals lined up. That's not intentional. I don't have to worry about doing that. 2 times 3 is 6. 2 times 2 is 4. 2 times 6 is 12. Add my placeholder 0. 4 times 3 is 12. 4 times 2 is 8 plus 1 is 9. 4 times 6 is 24. Add them together. 6 plus 0 is 6. 4 plus 2 is 6. 9 plus 2 is 11. 4 plus 1 is 6. And 2 plus nothing is 2. Now I have one move here, one move here. That's one move in each. That means I need to move it 2 times here. 1, 2. So my final answer here is 261 and 66 hundredths. That is part 1 of our study guide, and as you can tell, there's not a lot of mystery here. It's just straight up, can you compute these numbers? Can you follow those algorithms and come up with the correct answers? Keep in mind, when we were dividing with decimals, we had to think about moving those decimals. Same thing when we multiply with decimals. We want to move our decimals in a particular way, and if we don't, we're in trouble. Up here on the fraction questions, we have to worry about mixed numbers and turning them improper. Worry about whole numbers, turn those improper. We think about keep, change, flip if we're dividing. Otherwise, when we multiply, we want to make sure that we're going to cross-simplify to make life easier and come up with the simplest answer. All right, that is part 1. If you would like to refer to our video for part 2 of our Chapter 2 test, please check that out. I'll try to put the link into our description if I can. And good luck studying, and best of luck to you on your test.